Hello. Today I'm going to give you an introduction to substitution in indefinite integrals. So let's dive right in. Although we've recently learned how to compute area with definite integrals in the fundamental theorem, we're still limited by the types of antiderivatives that we can find. Essentially, we know how to do polynomials, some trig functions, and some exponential functions. We just don't know how to do enough antiderivatives yet. Luckily, substitution's coming to the rescue. Substitution's a technique for finding antiderivatives of compositions. In a way, it's a chain rule for indefinite integrals. It's probably best if we just dive in. First, I want to give you a couple of quick reminders. Remember, for indefinite integrals, something like the indefinite integral of x dx, there's really two parts to this answer. The first thing we want to do is figure out the antiderivative of x. That's like x to the first power, so we use our power rule. And the antiderivative, the capital F part, is x squared over 2. But remember, there are an infinite number of functions that have x as its derivative, so we have to add that plus c on the end. Now, this process is not limited to the letter x. As long as the function here is written in the same variable as the differential, the process works the same way. Specifically, I just want you to know that the integral of u du looks very similar. That would be a u squared over 2 plus c, right? The fact that we use letter u really doesn't affect the way we do the problem. And that could work for the letter p or the letter m, but traditionally you'll see in our examples here that we use u when we do substitution. Okay, now let's dive in. So here we have a pretty complicated function as part of our integral. The function is the quantity 7x squared plus 6 raised to the 5th power times 14x. And we are trying to find this indefinite integral, this antiderivative. Well, the only tool we have right now would be to multiply this thing out, probably using the binomial theorem, to multiply out 7x squared plus 6 to the 5th, and then distribute the 14x. And that is just not practical. A better way for us to work this problem is to recognize that we have a composition here. And we have this technique that I'm going to show you, which will allow us to simplify this definite integral. Basically, what we do is we convert this problem into a u problem by recognizing the composition. So, for example, you can see right here that this expression is a composition. That 7x squared plus 6 is plugged into the function u to the 5th. So when we do this thing called u substitution, the first thing we do is choose u. That is step one. And we almost always choose the expression in the parentheses. Now, I say that, but there will be a few exceptions as always. But for these polynomials like this, we're going to choose the expression in the parentheses for u. So I choose u equal to 7x squared plus 6. That's half of our battle. The next thing I need to do is take the derivative. And I'm going to take the derivative using Leibniz notation. So I'm going to compute du over dx. And I'll notice that that equals 14x. And then the last thing I do, so that's step 2. I guess I better label these. Let me put those in a different color. I'll put step 1 in green. 1 is choose u. 2 is get the derivative. And then 3 is solve for dx. And when I solve for dx, I think you'll agree that I end up with dx equals du over 14x. Okay, now step 4 is going to be to rewrite the integral. And I guess I have to put that over here. And let's make this new integral blue. Now, in step 4, we have two jobs. We are going to replace the expression that we chose with a u, and we're going to replace the dx with the thing that we computed for dx equals. Other than that, we're going to write the same integral. So check this out. The new integral is going to be u to the 5th power, right? I replaced 7x squared plus 6 with a u times 14x, and I replaced the dx with this thing down here that I computed, which was du over 14x. And if everything works well, any remaining x terms will cancel, like these guys do. And so my new integral becomes u to the 5th du. And we can simply use the power rule on this thing, right? We can write this as u to the 6th over 6 plus c. Now here's where the catch comes in. Our original problem was an x problem, right? This thing up here is an x problem. That's what I'm calling it because the variable is x. X problems need x answers. So down here, I'm going to put my x answer by replacing u with the original expression that we chose. So usually, that's a u joke there, usually you'll see this answer written as 1/6 times 7x squared plus 6 to the 6th power plus c. Usually, that will be the answer to this u substitution problem. Okay, so let's get a clean screen and let's write out our 4 steps, and then we'll try a few more problems. So rather than have you just watch me write all this stuff out, and since I'm too lazy to type it out and make it look neat, I wrote out the 4 steps here, and then we'll do some more examples. But anyway, step 1 is always choose u, and then our hint is to look in the parentheses. Again, we'll come across some problems where the parentheses aren't the place to choose u, but for the most part, when we first start learning u substitution, we look in the parentheses because that's usually how the composition is written. After you choose u, step 2 is to get the derivative, du over dx. For step 3, once you have that derivative in step 2, you solve for dx. And then step 4 is we're going to write a new integral by replacing the u and the dx in the original. If everything goes well, the rest of the x's will cancel, and you'll have a new u integral that you can find the u antiderivative of. And then at the very end, write your problem with x answers. Write your answer with x by substituting the x back in. Okay, let's see it in action again. In this example, we're going to find the antiderivative, or the indefinite integral, of 42x squared cosine of 7x cubed. This is a complicated function. It kind of looks like a product even. That's because it is a product. But there's also a composition. And you guessed it, this is a perfect candidate for u substitution. Just so you know, I'm going to have all kinds of u puns during the next several lessons. You will love it because you will not be able to stop laughing at all my u jokes. In this case, the composition is the 7x cubed was plugged into a cosine function, and so I'm going to choose 7x cubed as u. And then over here on the side, I'll get organized. I'll write u equals 7x cubed. Step 2 is to find that derivative, du over dx. And that's going to be what? 21x squared. Oops, let's write it correctly. And then when I solve for dx, I multiply by dx and divide by 21x squared, and I get dx equals du over 21x squared. Now remember, my job at this point is to replace the u and the dx. So up here, I'll put a u in where 7x cubed is, and I'll put a du over 21x squared where the dx is. So I'm going to rewrite the integral. I've got 42x squared cosine of u times the dx, which is the du over 21x squared. And as I mentioned before, if everything goes well, all of the other x terms will cancel. Well, that almost happens here. Notice 21x squared does cancel with 42x squared, except that there's a factor of 2 left over. Now, that's just a constant multiple. So as you're cleaning up this expression, you can write this as 2 times the definite integral of cosine u du. We've already talked about how we can factor constant multiples out of the way, do our antiderivative, and then multiply it on. At this point, we just need to know the antiderivative for cosine of u. Don't think too long about this one. It's obvious, hopefully. That's going to be the sine of u plus c. Don't forget about the plus c. Now, if you're thinking about this 2 and how we multiply it through to distribute on the sine of u plus c, don't panic. When you multiply this c, which is all the real numbers, by 2, you still get all the real numbers. So we don't have to put 2c here. We can just write plus c at the end. Our last step, in case you've forgotten, is to give an x answer for an x problem, right? This up here, this is an x problem. So we're going to give an x answer down here by substituting the u back in. So the final answer for this indefinite integral is 2 sine of 7x cubed, because that's what u was, plus c. And so this is the expression that we're looking for the indefinite integral of 42x squared cosine 7x cubed dx. If you're not sure about your answer, just take the derivative and see if you get the original expression. You will, as long as you follow the chain rule, right? This is a chain rule problem. So that's substitution. This is a brief introduction. I haven't shown you all of the idiosyncrasies, and I haven't really shown you a problem where the parentheses weren't the u yet. That's coming later. But this is a good introduction to u substitution for finding indefinite integrals of compositions. Once we get the hang of this, of course, we're going to go back to the definite integrals, because we're going to want to use this technique to help us find the area under more complicated curves. So stay tuned for that. In the meantime, good luck with your problems. You know where to find me. Take care.